we can write the first fundamental theorem of calculus would be like if we put as the integrand f prime, and then this would be just f of b minus f of a, right? Like that means the same thing. Are we okay with that? Okay, so let's think about a specific application. And derivatives we think of as being this formula that calculates rate of change. Well, a rate of change that we often think about is velocity, right? So like, let's think about what happens if we're evaluating a velocity function, okay? Which would be the same thing as evaluating the derivative of a position function over an interval. So if we apply, like if we think about integrating s prime, which is velocity, s is just a common notation for like a position function, right? If we think about integrating s prime, I'll put an extra step in here. This would be equal to s of t. And then when we apply the first fundamental theorem of calculus, we get s of b minus s of a. But let's like think about what does that mean? What is that number? What is s of b and s of a? So if we're talking about position, velocity, okay, position, s of b would represent what?
Final position.
Yeah, the position of an object at t equals to b. I'll put a little note over here, or I'll write it right here. Position at t equals to b. And then minus s of a would represent, yeah, position at t equals to a. So this means that when we integrate a velocity function on the interval from a to b, it's equal to the net change in the object's position from t equals to a to t equals to b. In other words, it's the object's displacement. When you integrate a velocity function over an interval, that number indicates the object's displacement. And remember, when we've talked about motion previously, we've focused on linear motion, like one of two directions. So you could think about if displacement is positive, it means that from the initial position, the ending position is like in the positive direction, whether that's forward, up, right, to the right. And if displacement is negative, it just indicates that that ending position would be in the negative direction. Like it would be to the left or backwards or down. But when we integrate a velocity function, that number represents displacement. So the net change in the object's position is the same thing as calculating the object's displacement. In terms of units, we would then want, like, if we're talking about displacement, like a number that represents displacement, the units would be a unit that we use for describing distance, right? And I want to justify this to you. And I can credit Annabelle for, like, this specific example last year because she was trying to wrap her brain around, well, like, why is the integral of a velocity function a change in position? Like, why is it equal to displacement or something that's in units that describe distance? So if we think about having a function so just some positive function, I'm going to call this function v of t. And we're focusing in on the interval between a area here would represent the displacement, right? Because it would be equal to the definite integral from A to B. If we take a step back and think about the definition of the definite integral, like we know that, okay, this would be equal to the integral from A to B of v of t dt. But if we take a step back and think about this definition, remember, like, this came about from thinking about adding up infinitely many rectangles, right? If we have a positive function, okay, on the interval from A to B, we're thinking about adding up the areas of infinitely many rectangles. If we were to just focus on one subinterval here, like one rectangle, where the width of the rectangle would be, I could call it like delta t, so that's my t-axis, and let's say that I'm determining the height by v of a or v of some value that lies on the interval. Well, the area of each rectangle that I'm thinking about adding up would be equal to delta x times v of c sub I, right? Not delta x, delta t, based on what I was using here. And let's say that delta t, let's say that t I'm measuring in seconds. Okay. And let's say that velocity is being measured in like meters per second. Like the output values of the velocity function would be in meters per second. So that means that delta t would be in seconds, and then times, well, velocity evaluated at some value on each of the subintervals would be in meters per second. Do you see how like the seconds would cancel? And the area of each of the rectangles would be a number that would be in meters. So you're adding up areas that are all in meters, meaning that this value, if velocity was in meters per second, like this number would be in meters. Do we follow that? Okay. Another example is if we think about integrating acceleration, that would give us, which is the rate of change of velocity. So if we integrate acceleration, that's the same as integrating v prime by first fundamental theorem of calculus. This definite integral would be equal to v of b minus v of a, which would be change in velocity on the interval from A to B, or the net change in the object's velocity from t equals to A to t equals to B. So this leads us to the net change theorem. So if capital F prime is the rate of change of a quantity, capital F of x, then the definite integral of f prime from A to B gives the total change or the net change of capital F of x on the interval. Okay, does everyone have their calculators? Pull those puppies out. Daniel's ready to go.
There's nothing on it. I needed it for the physics.
I don't know if I have a charger. I think people have taken my charger.
I lost my charger, so now I can't charge my
Buy an extra one on Amazon. I need to buy another one on Amazon.
Huh?
I think mine have disappeared.
Good could have just asked.
Bro, you attend class every day, you can't ask for it instead.
Can you use mine?
Arjun
Use my girl.
Arjun was gone.
I was in the Bronx.
Okay, so a cup of coffee
No.
at 90 degrees Celsius is put into a 20 degrees Celsius room whenever T is equal to 0. Okay, so a hot cup of coffee is put into a 20 degrees Celsius room whenever T is equal to 0. If the coffee's temperature is changing at a rate given in degrees Celsius per minute by R of T is equal to -7 times e to the -0.1 T, approximate the coffee's temperature after 10 minutes. We want to approximate the coffee's temperature after 10 minutes. Well, doesn't that mean we want to know what the change in temperature was from T equals to 0 to 10 minutes later? Wouldn't the change in temperature, so we want to calculate the change in temp from T equals to 0 to T equals to 10 minutes. Now that would be equal to the integral from 0 to 10 of R of T. And you guys have your calculators. You can also on paper write out the integral and use the rule for R of T, but if it's a calculator active question, you are welcome to reference it just by its function name. So this would be the same as the integral from 0 to 10 of -7 times e to the -0.1 t dt. Go ahead and type that into your calculator and tell me what you get. Obviously in your calculator you're using x's for the independent variable, not t. So go ahead and tell me what you get as the approximation there.
Whoa.
Negative, and for AP, for College Board, we round to 3 decimal places, so -44.248, and the units would be
I did -0.1.
degrees
Celsius.
Celsius, okay? Now, this isn't the actual temperature after 10 minutes. This is just the change in temperature. And you want to make sure you're paying attention to what a question is asking, because the question is asking us to approximate the coffee's temperature after 10 minutes. So this negative value that we get that represents the change in the temperature, that's telling us by how much that initial temperature of 90 degrees Celsius decreased. So if we wanted to find the actual temperature,
Subtract by 9.
or you can think about taking the initial temperature. So the temperature at T equals to 10 minutes would actually be 90 degrees and then subtracting the 44. Or wouldn't that be the same as 90 degrees plus this integral from 0 to 10 of R of T dt? So you guys, what do you get? If you take that value, that negative value, and add it to 90, or do 90 minus that value, 45.752 degrees Celsius. So that would actually be the temperature after 10 minutes. The integral from 0 to 10 represents the change in temperature. Right, if we were to apply the first fundamental theorem of calculus, we would have like capital R of 10 minus capital R of 0. Okay. Is that okay, you guys? How are we doing on time? What time are we out of here? Is it 27? So we have like just under 10 minutes. Okay. An automobile accelerates from rest at 1 plus 3 root t miles per hour per second for 9 seconds. What is the velocity after 9 seconds? Notice though, we are given that it accelerates from rest. Well, at rest, what's the velocity? 0. Okay, so we can just think about integrating from 0 to 9 because we know that the velocity was was 0 at t equals to 0. So from 0 to 9, integrating 1 plus 3 root t dt. This is something we know how to integrate. So that would be t plus 3 times 1 over 3 halves, right? Because 1 half plus 1 t to the 3 halves. I'm going to simplify that. So t plus 2 t to the 3 halves so 9 plus 2 times 9 to the 3 halves power minus, that'll just be minus 0. Which ends up being 3 cubed would be 27 times 2, so 9 plus 27 times 2. Thank you. Now, if the units here are miles per hour per second, what are the units on 63 going to be?
Miles per.
Just miles per hour. That would be the velocity at t equals to 9 seconds. It would actually be the change in velocity, but because we know it's the actual velocity at t equals to 9 seconds because the velocity was initially 0. So being given this little piece of information here is important. Let's see. Yes.
How come for this problem we did it by hand, but the other one we used calculator?
Because you don't know how to integrate the other one. It says it's calculator active. Okay. Let's leave out. We're just going to leave off on part A. I want you to think about this. So the graph of the velocity of a particle moving on the x-axis is given with that graph, right? That's a velocity graph. The particle starts at x equals to 2 whenever t is equal to 0. So if you're wanting to find the total distance traveled by the particle, do we have thoughts on how we would do that?
Excuse me, that was crazy. I apologize. Keep going.
That is crazy. Oh, you have the integral of this.
Yes, RG.
Well, let's think about it. If we calculated the integral of velocity, right? Like conceptually thinking about what that would represent, like if we integrated from 0 to 7 v of t dt, wouldn't that be taking this negative area plus this positive area plus this negative area? And that would end up representing whatever x of 7 minus x of 0 is, which we've said represents the integral of velocity over an interval represents displacement. Is displacement the same thing as distance traveled?
No.
No. Because the displacement would just indicate to us, like, based on, like, the starting point, like, your initial position, like, where did you end up? Like, what is the difference between that ending position, which is described as whatever x of 7 is, minus that initial position, x of 0. Okay, so that gives us our displacement. That's not what this question is asking for. This question is asking for the total distance traveled. Now let me ask you this. What if you had, like, if we were to integrate on the interval from a to b here, this positive velocity function, the displacement, that means, right, that the object was only going in the positive direction. Wouldn't the displacement then match up with distance traveled? So what we're trying to figure out is, like, what was the distance traveled in the negative direction, the distance traveled in the positive direction, and the distance plus the distance traveled in the negative direction. This we know would represent, like, if we thought about integrating velocity from 0 to 1, we can see we would get a negative value that would represent the object's displacement, or the particle's displacement, between 0 and 1 second. And that tells us the negative would indicate that it went in the negative direction, right? Whatever that number is, it would be negative, and that indicates that the displacement was in the negative direction. So what if we thought about taking the opposite of this area plus this positive area plus the opposite of this area and added up those values, right? Because the positive, the opposite of this negative area would represent the actual distance traveled between 0 and 1. The opposite of this negative area between 5 and 7 would represent distance traveled between 5 and 7 seconds. Do we have units on here? We'll just leave it there. I'm going to have to adjust the assignment. I knew going into it we were going to probably have to adjust the assignment. But we'll wrap this up the beginning of next class. Yeah. Stay healthy.